This is Harvard on the Map, presented by the Harvard Graduate School of Design, covering innovative ideas and thought leaders in digital cartography, Earth observation, and all things geospatial, with your host, Jennifer Horowitz.
Hello, and welcome to Harvard on the Map. I'm here with Walter Scott, Dr. Walter Scott, who is the current CTO and Executive Vice President of Maxar. He's also a proud Harvard alum and a former member of the Harvard radio program. It's great to have you on the program.
Great, thanks. Appreciate it. Do they still call it Werbies, or is it a different name now?
I did do WERB in as an undergrad, but this is the graduate radio program. Yeah. The same station, but yeah. So first, to preface, the theme of today's interview is things I wish I knew before entering the geospatial industry, completing the sentence with some advice for younger geospatial analysts entering the geospatial job force. But first, if you wouldn't mind maybe speaking to your own background from your PhD in computer science to your role at Lawrence Livermore and how you came to be at Maxar.
Sure. Well, getting out of Harvard, ended up not really knowing what I wanted to do, actually. For 4 years at Harvard, I skated through a number of different disciplines and realized that the thing that I really enjoyed was building things. And computer science was a way that I could get instant gratification in building things. Somewhat ironic that I ended up going from computer science to actually building satellites, which is definitely not instant gratification. And as part of that, I was pursuing a PhD in computer science at UC Berkeley. And I started doing some consulting work at the Livermore Lab, working on Unix, early Unix operating systems and building a public key crypto system for email and some other fun stuff that was very early days. And while I was there, I got invited to join a program that was part of what was called Star Wars at the time, or the Strategic Defense Initiative, building a space-based network of interceptors called Brilliant Pebbles that were designed to shoot down Soviet missiles. And it was in many ways a predecessor to today's CubeSats, which are very small satellites that take advantage of commercial microelectronics. It was definitely ahead of its time. It was something that was very much pioneer. My forehead is flat from pounding my head against the wall so many times during that, as most tech pioneers tend to find. And from there, I saw the end of the Cold War happening pretty much with a ringside seat. And one of the things that kept the Cold War cold was satellite imagery. It was the ability to act on the basis of facts and not on the basis of fears. And so that was this idea that was just sort of running around in my head. And I was playing paintball with a friend of mine. We had a long drive back from a paintball game, and we were talking about the state of the world and just coming back to this idea that global transparency was a really good thing. And why was it that it was only a few governments that had the benefit of global transparency? And so that was really what led to the idea of starting Digital Globe, that eventually got acquired and formed into Maxar. So that's my life story in a few words.
I appreciate it. Yeah, very synthesized. You gave a wonderful talk at the C School recently, which I really enjoyed, and it was a more comprehensive history. But yeah, I appreciate it. Actually, I'd wondered about Lawrence Livermore, since it's not a national laboratory that's typically associated with space infrastructure work. I'd always wondered. So it's really interesting to hear how you made your way through. So to start, Maxar broadly is very broadly broken up into two sort of parts, the space infrastructure side and then the geospatial analytics side. Do you think that as a younger geospatial analyst, it's important to familiarize yourself with both parts? Do you think that that understanding both sides of it is essential?
In the early days of the geospatial industry, there were no satellites. Everything was done surveying on the ground, maybe with airplanes. But increasingly, you find that the world's a really big place, and one of the best ways of getting data around the entire world is from satellites, whether it's using GPS for positioning or satellites for imaging. So there's at least a need to understand enough about where the data comes from. Whether you necessarily know how to build the satellites, probably less important, but I'll tell you some of the things that I learned early on in starting Digital Globe and being in the geospatial business. It's actually a lot harder than it looks. Just to pick an example, we collect 30 centimeter resolution imagery from hundreds of miles in space. And that's analogous to being able to pick out the ear on the president's face on a dime from a distance of a couple of miles. So, you think about, there's a level of precision there that's pretty amazing. Also, the Earth is pretty messy. You can see in the photo behind me that there are these mountains. They're bumps on the surface. The Earth isn't round. It's not flat. It's not round. And that turns out to matter a lot if you're trying to figure out where something is on the ground when you're looking at it from space. You've got that perspective view, so you need the elevation data. So there's an understanding of like, where did my data come from? That's really important if you want to be in a field like geospatial, because you can't always take the data at face value. You need to understand that you can rely on it. Is it telling you something that actually represents reality or not? And so that's one part. I think the other part is that we're starting to see in the space world more and more capabilities that are moving out to the edge, meaning capabilities that are being put on satellites. And I see that trend only increasing. It used to be the satellites they had very limited compute capability compared to what you have on the ground, but with some tremendous advances that have happened in electronics over the last couple of decades, you're now seeing very capable computing platforms on satellites and interconnection. So I think the boundary between the geospatial world and the sources that feed the geospatial world is getting more blurry over time.
That's fascinating to hear you say that. Yeah, wow, from the horse's mouth. It's interesting to hear you talk about both sides of the business. I wonder, your background in mathematics and physics, engineering. Would you say in your day-to-day role now that at a CTO level, is there any computational work that you do, or is it mostly a more strategic, bird's eye view sort of deal?
Yeah, that's a good question. I don't actually get to do stuff much anymore, but I do read code. I do poke at engineering analyses. It helps to be able to ask lots of questions. One of the nice things about a CTO job is it gives you a license to ask lots of questions. So I get to learn a lot. There's a huge amount that almost an infinite amount that I still don't know. And so it gives me a wonderful opportunity to be asking questions of really smart people and learning more about a particular area. And I find often that the process of my asking questions helps me learn, but it also helps the people I'm asking the questions of better understand what it is that they're doing. Because, sometimes the questions are not very well informed at all. Sometimes they are. And so it's a way that we both get something out of the equation. I think the last time that I actually wrote code was probably, I don't know, other than, a little application that I do here and there for my own purposes, probably 15 years ago.
Wow. Interesting. Well,
sad actually. But.
I just finished my last computer science final about an hour ago. So that makes me feel sad, but also I guess if you love it, you do it. And if you don't have to anymore, then that's good too.
Well, it was, for me, it was a form of being able to create and to build something.
Sure.
And like I said early on, that was something I realized in my undergraduate that I really liked. I liked building things. You take something that's a concept and it becomes real. Whether it's in bits or in atoms, it becomes real. And that was, for me, that was very rewarding.
Yeah.
If the thing that you built then could do good even better. And what was interesting about this idea of global transparency is that it contributes a lot to good. And whether it's work that we've done with like the Associated Press that involved their investigation of seafood from slaves that resulted in freeing 2,000 slaves, work that we do in supporting the COVID crisis around the world, work after disasters, or just shining a light on where governments around the world are doing bad things to their people. It's nice when you can combine all those elements together.
Absolutely. Part of the reason I'm really loving my work at Maxar, every single time I read another blog post about some humanitarian use case or otherwise, it's environmental. It's fascinating, the different use cases, and it's also just amazing. My next sort of question, I guess, is more specific to skill sets. You mentioned you haven't written a line of code for 15 years, but would you say that there's, on a programmatic level, are there specific skill sets that you'd recommend, geospatial analysts accrue, whether those be on the AI/ML side or otherwise?
The class that everybody liked to hate in college was statistics, and it turns out that's one of the most useful skills imaginable. It's like it has applications so many different areas, and actually learning how to think statistically turns out to be just a very useful. You do it enough, you start to develop enough of an intuition about it. It's very useful for how you view the world. I think as you learn more about the applicability of AI/ML to very large data sets, that's a very useful one as well. And I highly encourage people to learn how to code, because that's a way that you can build without having to use atoms, but you can build things that are in short order can do amazing things. And I'd say those are the main ones. Learning how to think analytically and critically underpins all of that. The geospatial world, when I was a grad student at UC Berkeley, I was developing computer-aided design tools for development of integrated circuits. And we thought that was hard at the time. And then you go to the geospatial world and you realize that was like kindergarten compared to the geospatial world. Because in the geospatial world, you've got all this messiness you have to deal with. Roads aren't straight. There are trees over roads. The road's still there, even though you can't see it through the trees. You have, one of my favorites is addressing. In the United States, we're used to think of addressing in kind of the Roman model. Things are sequential along a street. Then you go to Tokyo, and they're numbered in the order in which the building was built. So just a recognition that you've got to open up your aperture wide and apply tools geographically different. Pick another example. So we've done a bunch of AI/ML for recognizing buildings around the world. It depends on where you are in the world. Buildings look different. And a structure in parts of Africa will look very different outside of an urban environment, will look very different than a structure, say, in the middle of Boston. So there's just sort of recognize that the toolkit's got to get a lot broader. Just one more thing I'll say, AI/ML, we're only starting now to see the real applicability of that to what has historically been considered remote sensing. And, if you were to look at a remote sensing text of, even 10 years ago, it would talk about things like spectral angle mappers and principal components analysis. And what we're now starting to see are these empirical AI/ML models outperforming the traditional remote sensing techniques. And to me, I get the sense that we're still just sort of in the acceleration phase of the application of AI/ML to extracting patterns and information. There was a company that we work with up in Canada that does remote sensing for geological exploration. and they showed that if you use traditional techniques for shortwave infrared and compare that with applying an AI/ML model, you got a better result with the AI/ML. And I think in part because it was starting to recognize geomorphological features that a trained geologist would recognize as indicative of certain mineral deposits, in addition to just the colors that you got from the spectral.
Yeah, that's fascinating. On the space infrastructure side, those are really large projects, and those go beyond engineering to managing a team and making sure that things are moving in the right direction. So I wonder what skill sets you'd recommend, younger people who are entering the geospatial profession can accrue outside of the technical to in terms of a longer term skill sets to accrue.
I think one of the most useful skills that's a non-technical skill is learning how to communicate effectively. And one of the best classes I took in high school was a speech and debate class, because it forced you to, first of all, to be able to think on your feet, to be able to talk in front of a group, but it also forced you how to organize your thoughts in a way that was clear, concise, and understandable by somebody else. And that turns out to be valuable, not just in sort of the up and out communication when you're talking to customers or you're talking to other organizations or you're being interviewed for Harvard on the Map. It also helps when you're working with a team, because being able to communicate effectively means it forces you to put yourself in the shoes of the person that you're talking to. Because if you can't communicate with that person, you've failed. Well, you're not going to communicate if they don't understand what you're saying. So you have to do a certain amount of putting yourself in that person's shoes. And I think that, I wouldn't say that I have intrinsically a high EQ, but it certainly got improved by learning more effective communication skills.
Fair, totally fair. Yeah. Final question that I ask everyone on the program is to describe a time you were lost, whether that be physically or metaphorically in your life or career, and how you found your way back again.
So I guess from a geospatial standpoint, I've never been lost. I've wandered a lot, but I've never really considered myself lost. I spent a year going to school in Edinburgh and would visit various cities in the UK, and I would like to just get on foot and walk around and begin to build a view of where I happen to be. But from a career standpoint, I'd say that the point that was probably the most lost was that we built a satellite called Early Bird 1 back in the late 1990s. And we launched it on a Russian rocket. And the launch was successful. Satellite's on orbit, it's doing its thing. So, woohoo, vodka toast, high fives, take the plane back to Moscow, connect from Moscow to Paris, back to San Francisco, Bay Area, which is where I was at the time. We get off the plane, we learned the satellite had died. And figuring out how to pick ourselves up and move forward again was a real challenge. And I'd say the things that enabled me to do that were my coworkers, my friends, several of whom were part of that paintball conversation. And most importantly, my wife, who was very supportive. And so it was that support network that enabled me to keep going. And many of the people who were there at the beginning, there are some of them who are still around, and I consider them friends.
Wow. Yeah. You mentioned this story a bit in the C School talk that you gave, and it really is amazing. I don't think I even fully appreciated, in addition to the incredible humanitarian work that Maxar does, one of the very inspiring things I think is just an amazing tribute to the work that Maxar does is that it is really a comeback story. If QuickBird hadn't launched, I don't know, what would have happened, but I think it's just amazing to see, that perhaps one of the most, successful or space infrastructure companies in American history has almost came to insolvency before, before it became a massive success. It's
Well,
really
it wasn't just once, it was twice.
twice,
And
right?
it wasn't just Digital Globe. It was also Space Imaging had its first launch fail. Orb Image had its first launch fail. For a while, the industry was known as the industry famous for blowing up the most satellites. And it just took a while for us to get our legs underneath us. But, space is hard. And you saw the same story with Elon's SpaceX. By the way, if somebody were to ask me if I had the ability to do things over again, what would I have done? I would have started a software company and then started a space/geospatial company instead of the other way around. I think Elon had a better model than I did.
That's true. You could have been on SNL last weekend. That would have been
Probably not. I don't have quite that aspiration.
fair, totally fair. Well, I appreciate you coming on Harvard on the Map, and it's an honor to talk with you a bit and get your thoughts.
Great. Well, thanks, Jennifer. I really appreciate it as well. And best of luck to you. I see you've got a beautiful Charles River background behind you.
Yep.
Yep. Great. All right. Well, take care.
All right. Thanks. Bye.
Yep. Bye-bye.